Okay, it's Mr. P helps. This is Algebra 2, Unit 2, Topic 2, SLT number 11. We're getting into polynomial functions again, but we're going to be talking about end behavior, and we're going to be talking about how the even or odd degrees change. Now, not even and odd functions, we'll get to that in another video, but just the degree of that function. All right, so this is kind of what we did on the last lesson. Identify the degree of this function. This is a degree of 2 because 2 is the biggest exponent. The leading coefficient would be 1 because there is no number in front of the x squared, so it's just 1 because anything times 1 is itself. And the most amount of answers this can possibly have is 2. So whatever the degree is, had it been degree of 5, the most solutions it could possibly have is 5. Sketching this graph. Now you can use a graphic calculator, but there's a way to do this without a graphic calculator. It's in standard form, so -4 is the y-intercept. It's right there. And then I can factor this and change it to x minus 2 times x plus 2. It's differences of squares. Because remember, the outsides and the insides are going to cancel each other out. So all you're left with is x squared minus 4. And that tells us the two roots. The two roots are going to be positive 2 and negative 2. Now you've got enough because that y-intercept just happens to be the minimum amount. That's not always going to happen, but there was no transformation left or right here, so I could do this pretty easily without a graphic calculator. That's not always going to be the case. You can always just put this in a graphic calculator and press graph and see what it looks like. Copy off the table. How many solutions does this particular function have? It has 2 because it has 2 intercepts. 1, 2. 2 x-intercepts. The end behavior. So as we're going to the left, the end behavior is going up towards, now I'm just going to write this out for right now. Later on, I'm going to write this out in the correct manner. So as we're going to the left, so if I start here and I trace it going to the left, why would I have that color? As I trace it to the left, it's going up towards infinity. So I'm going to say as I go left, it's going up towards infinity. And as I'm going to the right, it's also going up towards infinity. Now, it's not always going to be the case. It depends whether or not it's an even degree or an odd degree. And it also depends whether or not the leading coefficient is a positive or a negative. It went up on both sides since it was a positive, but if it was a negative, it would have been flipped upside down. If you remember from Algebra 1, when you did quadratics, if it was negative x squared, then it flipped upside down. All right. So, bunch of notes here again. So, multiplicity is the idea of how many times that answer repeats in the question. So, had the polynomial been x minus 1 times x minus 1 times x plus 2, then that x plus 1 is actually squared. It actually happened twice. This is really x minus 1 squared times x plus 2. So the multiplicity of this root is 2 because that's how many times it occurred. Whereas the multiplicity of this root only happened once because there is no exponent, so it's really to the first power. So this answer of 1 happened twice. This answer of -2 happened once. And that's all you're really seeing up here. So there's one answer of -3, because remember when you set it equal to 0, it's always going to be the opposite. This answer is actually 2. And then over here you can see that x plus 3 has been done to the 4th power, so it has a multiplicity of 4. So you could say that -3 happens 4 times and +2 happens 7 times. It has a degree of 11 because when you're multiplying, it's a total amount of the two put together. All right, over here, this is a big, long polynomial over here. There's lots of zeros. There's a -5 right there. There's a -2 right there, a +1, and a +5. So those are the 4 different roots, and then this 3 out here represents actually a imaginary root, which 3 cannot ever equal 0, so that doesn't really make any sense. That's imaginary. So these are all the factors right here. So x equals -5 with a multiplicity of 3 because it happened 3 times. -2 happened 4 times, +1 happened twice, and +5 happened once. Because as you can probably clearly see, all I'm doing is using the exponent that goes with that factor. So this is an answer of -5, has an exponent of 3, so that's the multiplicity. That's how many times it occurred. All right, so now breaking it down a little bit further. So when you look at these signs, and I know I'm not reading through it because I really just want to make sense of this. I'm not going to read through this as well. The root is right here. There's 2 answers right here, -6 and +7. -6 and +7. In fact, all 4 of these graphs have the same 2 answers. -6, and +7. Now, you're probably wondering, why don't all four graphs look exactly the same if they have the same solutions? Because they don't have the same multiplicity. Because this one has a multiplicity of 1 and 1, this one's 1 and 2, this one's 2 and 1, and this one's 2 and 2. Now, there's an easy way of identifying whether or not the multiplicity is odd or even. And the way you determine that is if the line goes through that answer and goes to the other side, it's odd. This line also goes through the answer and to the other side, it's odd. But what happens, well, this one's odd, as you can clearly see. So this is 1. 1 is an odd number, so it's going through that answer and past it. But on the other side, it's hitting that answer and it's going back up. It's not going through the answer to the other side, so therefore that must be an even. So evens always kind of look like this. Now, if it's x to the 4th, it's going to look a little different. I know it's really hard for me to draw. It's going to have a little bit more of a stay right here. But x to the 2nd, x to the 4th, x to the 6th, x to the 8th, x to the 10th, they all kind of look the same. So that might be x to the 10th right there, and that would be all negative x because they're all facing down, keep in mind. But that hopefully gives you the idea here. So if it's an even number, it's going to look like that parabola because it's going to touch the answer and then it's going to go right back up. Now this one's even here first and then it becomes odd because it goes through the answer. These are both even. I know that because it's going to touch the answer, go back up. Touch the answer, go back up. So both of these multiplicities have to be even. All right, third set of notes, probably the most important for this video. There's a lot of good stuff in here. Determining end behavior of odd and even degree functions. Now, we'll talk about odd and even functions later on, but this is just the degree, just whether or not the degree of the function is odd or even. Because the degree has to be one number. It has to be either odd or even because all numbers are one or the other. Well, all whole numbers, I should say, because remember, the degrees have to be whole numbers to be a polynomial. Now, in this case, if it's an even degree, if it's like x to the 4th plus x to the 3rd plus, it doesn't matter. As long as the degree is 4 because it's the biggest exponent. So if it's an even number, well, then what you're going to do is you're going to look at the leading coefficient. So it's either going to be positive like these two or it's going to be negative like these two. Both of these graphs are going up on both sides, and both of these are going down on both sides. So end behavior just means how does that function behave at the end of the graph, or at both ends, I should say. So on the right side and the left side, because it's going up for infinity. We can't give the highest point. There is no highest point. There's no maximum. There is no maximum here because it's going up infinitely. So that's why we call it end behavior, because it's just behaving at the end. It doesn't actually have a maximum point. We can't label that. So at the end of this one, it's going up infinitely, so we would say towards positive infinity. So this one's positive infinity and positive infinity. This one's going negative towards negative infinity and negative infinity. Now, what you'll notice when it's an odd degree, so when it's x to the 3rd or x to the 1st or x to the 5th, it doesn't matter. Any odd number. It's going to do opposites on both sides. So I call it, that's like discoing because it's making that disco. You got one hand going up and one hand going down. Sorry, that's just me. That's what I call it. So the left side's going up, the right side's going up, left side down. Sorry, I said the wrong thing. And right side up. If your coefficient in front of it is negative, it's going to do the exact opposite. It's going to be going up on the left and down on the right. Up on the left, down on the right. Now, you might have some, like, bumps. That's what I'm going to call them for right now. It's going to have these peaks in the middle, or crests, I guess you could call it. But those do not change end behavior. So as long as it's an odd degree, it might have a bunch of crests in the middle, but it's always going to have an end behavior on the left side going down infinitely and up infinitely when the leading coefficient is a positive. So knowing that, I'm going to use that to fill out these answers. This is a linear function. I know that's linear because it has a degree of 1. It's linear. And linear means it's a degree of 1, which means it's an odd function. So I look back at that notes, and I see odd functions over here. It has a leading coefficient of 2. Remember, don't use the 3. It's the leading coefficient of the biggest degree. So x to the 1st, that's the biggest exponent, which is the degree. And the leading coefficient of that largest variable with the largest exponent, that variable with the largest exponent is 2, which is positive. So I'm only looking at the positive one. So when I look at my table, I'm looking for the positive, which is these two. So left side going down, right side going up. So as x is the left and right, f of x is your height. So hopefully you did function notation in Algebra 1. So as x is approaching left, which is negative infinity, left is negative. So as x is approaching left, what is happening to the height? The height is going down towards negative infinity. As x is approaching to the right, what's happening is the height is going up towards positive infinity. All right, this one is quartic. It has a degree of 4. That's an even number. And remember, even functions, even degrees, either both go up or both go down. In this case, it has a positive coefficient, therefore it both goes up. So as you go left infinitely, it's going to go up infinitely, and as you go right infinitely, it's also going to go up infinitely. All right, this one right here, that's a quick and easy one. That's not even a polynomial because that does not have a whole number as the exponent. This one it has a degree of 3, so that one's odd, and it has a leading coefficient that's negative, which means it's going to go left infinitely. It's going to go up infinitely to the left, as x is approaching negative infinity, f of x is going to be going, so this is going down, so it's going to be going up infinitely. It's going to be approaching positive infinity. This is an odd function. Remember, it's kind of like the disco. It's going one up and one down. So as x is approaching positive infinity, that means to the right, f of x is going down. It's approaching negative infinity. This one over here is also not a polynomial because this is irrational. Well, this says, okay, square root of x is the same thing as x to the 1/2 power. And remember, like we said, polynomials have to have whole numbers as their exponents, and 1/2 is not a whole number. This one has a degree of 2, and the reason why is because this is a degree of 1, this is a degree of 1, and whenever you're multiplying two things by each other, you add their degrees, kind of like the laws of exponents. And x times another x is x to the second, you add the exponents. So this is really squared, and this is an even degree, and since it's even, they're either both going up or both going down, and since the coefficient is negative 2, they're both going down. So this would be negative infinity and negative infinity. This one, we have 1x here, 1x here, and 1x here. Keep in mind that all of the exponents of all those parentheses are all 1. So this has a degree of 3. That's an odd degree function. 3 is the leading coefficient, which is positive. And since it's odd, that means it's going to be going down towards infinity to the left and up towards infinity to the right. All right, so this is the exact same thing, only it's with graphs. So the type of function, this is linear. It has a degree of 1. It's an odd function. And it obviously, clearly, you can see that to the left, as x is approaching to the left, its height is going down towards negative infinity. As x is approaching towards positive infinity, that means to the right, its height is going up towards positive infinity. All right, I don't think I have time because I'm already at the 13-minute mark to do all of these. This one's clearly not a polynomial because that's curving up, that's exponential, that's like 2 to the x. Therefore, the exponent is not a whole number, so that's not a polynomial. This one is. All polynomials will do the same thing. So all evens will both go up or both go down. All odds will be 1 up, 1 down, and so forth. This one has an asymptote. That's another clear giveaway. It's an asymptote. It's not going down towards for infinity. Whereas all even and odd degree functions will either go, one side will go up and down infinitely, or both up and down infinitely. So not just hitting an asymptote, it'll hit all. So I guess I should say all polynomial functions have a domain and range that's all real numbers, is a better way of saying the same thing. Taking a look at a couple of these. This one's both going down, so this has to be an even degree. So this one has to have a degree of at least 2, and I could probably get into that a little bit more. I know I'm running out of time. It could be 4, could be 6, could be 8. We don't really know. We do know that the degree has to be at least 2 because it has 2 changes in direction. So it's going up and then it's going back down, so that's 2 changes. So this is going up and then it looks like it stays and then it goes up again. So this looks like up stays the same, then up again, so that's a degree of 3. This one I pretty much know because otherwise, had it been something else, it would have had a little dip in the middle. So that's an odd function. Its end behavior, clearly you can see it's going down to the left and up to the right. I think I'm going to have to call it right there because I'm running down to about 15 seconds left. Thanks again for watching. Have a wonderful day. Please give me a like and follow future videos if I helped you learn anything about polynomial functions, odd and even degrees, and what else do we do? End behavior. End behavior. Great. Awesome. Thanks. Have a great day.